Good evening and welcome to Irvine Valley College. My name is Stephanie Barger with Earth Resource Foundation. We're a local nonprofit here. And first of all, I would like to thank the Green Team Alliance of Irvine Valley College for putting this all together, but more importantly for all their amazing efforts at Irvine Valley College and beyond. They've made huge strides in I think the just 2 years you've been in existence. So if we could all give them a big round of applause. 1 year. So this is definitely what keeps us all hopeful is you young people getting involved and taking action. So with that, I would like to introduce our guest of honor, Mr. Captain Charles Moore from the Agalita Marine Research Foundation. He is a very dear friend and an amazing mentor to myself and many others. He is also a man of huge wealth, and we're not talking monetary wealth. He is a man of wealth of knowledge of the seas and the oceans and plastic, which we'll learn about. A man of wealth of friendship and generosity and his incredible love for all of us and for all the creatures on Earth. And he's going to give us about an hour and a half presentation, and then we'll take question and answer afterwards. And for those viewing us remotely, we will have question and answer at the reception immediately following. So a warm round of applause for Captain Charles Moore.
Thank you. Thank you very much for this opportunity to address multiple audiences here at the college, and we hope that the presentation goes without technical flaws. That's always nice. So I'm a local guy, born and raised in Long Beach, California, third generation Long Beachian, and I think my motivation comes from seeing the gradual deterioration of the water quality in the nearshore marine environment, living across from Alamitos Bay and growing up on the bay. As I was saying at dinner, I learned how to swim in a Red Cross sponsored swimming class in Colorado Lagoon, which later came to be called the Polio Pit and now is posted with an F for no body contact because of bacterial contamination. Would never think of holding a public swimming class there today. This kind of gradual deterioration, both in the chemical contamination and in the plastic contamination of the marine environment, was visible to me on a daily basis. And the fact that after a certain point I couldn't take my daily swim in my own bay that I grew up next to and virtually became a marine mammal in, was disturbing to me. So I think when people ask what motivates you to work towards restoration of the marine environment, it's a very personal motivation. Now, I want to be very clear about what I did and what I found out, because it's made quite a splash, and I want to give you the details of what I did and what I found out. And what I did was I built a research vessel. After having sailed all my life, I realized that if I was going to conduct marine research, I would need a stable platform. And the way you get that in a short boat relatively inexpensively is by creating a catamaran. A catamaran has a wide stance, and it's not subject to those harmonic forces that add together. A monohull, a wave will hit it, another wave will hit it. Each wave will be additive, and the boat eventually gets to rocking violently. That doesn't happen with a catamaran. The two hulls are spaced wide apart, so when one wave is impacting one side of the hull, the other side of the hull is not being impacted. So it doesn't receive these additive harmonic forces that create a very unstable situation. A catamaran is the easiest way to get stability and conduct marine research in a small vessel. Now, we built this from the ground up. We found a designer in Australia, Locke Crowther, who was a pioneer in building catamaran workboats. And this was in a catalog. He'd built a vessel like this for the Australian Museum to work at the Lizard Island Research Station in the Great Barrier Reef. There was only one other boat built to these plans, and I sailed on it and realized I needed to make some changes to make it a good sailing vessel, and I was able to do that with the help of Richardson Devine Marine Constructions in Hobart, Tasmania. Toby Richardson had been a whitbread around-the-world sailor and knew what it took to build a good sailing ship, and we changed the position of the mast, and we also made a flush deck on it. And this is what it looks like. Also, I had another requirement to get it into my dock in front of my house on Alamitos Bay. It needed to go under a 12-foot bridge, and that mast there is 70 feet from the water line, so it has to come down. It's on a hinge, and we lower that mast, so we're like Don Quixote tilting at windmills with a mast sticking 40 feet over the bow of the boat when we come through, and then we raise the mast back up once we get on the other side of the bridge and can navigate to our dock. You notice also that it's a sailing vessel, and that's what allows it to make these long voyages such that we can study the great Pacific Ocean, which is 1/3 of the surface area of the planet. Take all the other oceans, put them together, that's 1/3. All the land together is 1/3, and the Pacific Ocean is the other third of the planet. A truly amazing, incomprehensible to most people, the size of the Pacific Ocean. And we can access it by sailing. We would never be able to carry enough fuel to make the trip to the deep reaches and then have fuel for conducting the research if we weren't able to sail a large proportion of the time. So we are able to do that, plus the mast affords a vantage point for spotting ocean debris. The principal manner in which we study humanity's plastic footprint in the ocean is through the use of a surface trawling device called a Manta trawl. It's similar to a manta ray in that it has these wide wings and a wide mouth, and it skims over the surface of the water. It's very effective in capturing surface debris. It's about 20 centimeters deep, this opening, and the hood there prevents waves from breaking over it so that you really don't miss anything. It's a very rigorous sampling device in the sense that you can be pretty sure if you're not operating in more than, say, a force 5 or force 6 sea state, that you're going to be getting every object that is hovering near the surface of the water down to about 20 centimeters. Occasionally we will put a salmon ball on there, a lead weight to hold it down when it's a little bit rough, but a lot of the time we don't even have to use that in order to conduct proper sampling. Once that net is pulled back on board, we remove what's called the collection bag or the cod end. And this is me removing tiny plastic fibers from this 1/3 of a millimeter mesh net. The typical usage for a net like that is sampling what's called zooplankton. Zooplankton are animal plankton. There's different what we call trophic levels in the ocean, meaning different levels where feeding takes place on different types of organisms. The phytoplankton feed on minerals and nutrients in the water and conduct photosynthesis in the same way that plants on land do. Phyto meaning plant. The zooplankton are somewhat larger, and the animals eat the plants. The zooplankton consume the phytoplankton. So this is not a net designed to catch phytoplankton. It's the next trophic level up that we're capturing with this net, the zooplankton, 1/3 of a millimeter and greater. So this map shows our body of work. Each one of these dots represents a time in which we have deployed that trawl, that Manta trawl, in the Pacific in order to obtain a sample for analysis. And this one particular area here has actually 3 sets of circles there, because that's where we did our original research in 1999 and discovered that the plastic that we had obtained in that cod end of the net compared to the plankton we obtained in those same trawls outweighed the zooplankton by a factor of 6 to 1. There was 6 times as much plastic by weight in those samples as there was naturally occurring zooplankton. So we wanted to verify that, see how that changed over time. So in 2008, in the wintertime, our first trawl was August 1999. Then in the winter of 2008, we went back there and did the same stations again, 11 stations. Then in 2009, 10 years on, a decade later, we went back and monitored that area again so that we could see a decadal change. It's a common technique for looking at changes is to monitor them over the scale of a decade. Now, you can kind of see that the area that we surveyed correspond to loosely this NOAA diagram of the convergent zone here. This rose-colored oval is their rendition of what's known as the eastern garbage patch, an area that has recirculating currents even more so than the gyre itself. And the convergent zone they're showing is where they believe the highest concentrations might be found of marine debris. Now, that NOAA diagram is just produced last year, but this diagram was from a 1950s California Department of Fish and Game pamphlet on the migration of albacore. And you can see the same phenomena here in their rendition of the North Pacific currents. You can see this arrow recirculating back here, so kind of you'd think there is an area of recirculation here. Same thing over here in the western Pacific, and there is a western garbage patch, so-called, in that area. So it's not as if these phenomena were unknown to science. They've been known for over half a century. It's just that it wasn't realized that this would be the repository for our plastic footprint, humanity's plastic waste coming to reside there, as sort of a graveyard for our plastic. This was the concept we elaborated with our research. Now, how does that form? This is a very nice diagram done by James Ingram Jr., whose life's work was to model Pacific Ocean surface currents for the National Oceanographic and Atmospheric Administration, NOAA. Every 3 months here, he took the average of the surface pressure and plotted it. And what you're seeing is a kind of a time lapse over 13 years of the surface pressure every 3 months. Now, the way that this mountain of air is created is through a very simple process which is easy to understand. The sun impacts the equator more directly and heats the atmosphere hotter than anywhere else on Earth. So at the equator, air is being heated, is being replaced by more air flowing in. That pushes the air north and south. As it cools and condenses at the pole, it leaves this mountain of air in the mid-latitudes. And this mountain of air here, this H symbolizes the peak of that mountain. So that although you see it moving around in the North Pacific Gyre, its locus of points is fairly stable here in this area of the eastern garbage patch. That H, underneath that H, the surface of the sea is rather calm. What it amounts to is this peak of air actually is heavier. The peak of the mountain represents more air represents more weight. It's descending, and in the northern hemisphere it gradually moves in a clockwise direction, so that that H could be thought of as corresponding to a little bit depressed sea surface level, so that the sea level itself is a little bit less there. You can see on this chart of sea surface anomalies here where lower sea level is in the blues, that area of the eastern garbage patch is a little lower. So this is how I use the analogy. We've got a clockwise swirling current with a little depression near the center from this high pressure system, and that is where I get the analogy of the toilet bowl effect. This is similar to that lower part in the toilet with the water swirling around the edges, bringing stuff from the Pacific Rim and channeling it into this cemetery for our waste. You can kind of see how that could happen due to these physical forces in the atmosphere. The wind is what drives the currents. The currents themselves are created by the motion of the atmosphere and then brought to that repository there in the eastern North Pacific. Now, if we look at this in slow motion, this is some more of James Ingram Jr.'s work. He's now retired, living in the Seattle area. But he did this diagram for me because of the fact that I was puzzled why I was finding so much Japanese debris out in this area when it was actually closer to the United States than it was to Japan. And yet most of the debris we were finding there was Japanese in origin. So he made this simulation for me, and he's very good at doing these simulations. He actually plotted the Nike shoe spill, a container of Nike shoes spilled off a ship, and he plotted to the day when they would arrive on Oregon and Washington beaches so that the beachcombers could go down there and sure enough find these shoes washing up on the beach. So here we have some simulated debris from Japan, simulated debris from the northern Pacific coast. And after just a half a year, you see that's quite a different route that the debris is taking. Our debris is being caught what this rather fast-flowing California current brought down here past Cabo San Lucas and heading down below Hawaii, whereas the Japanese debris has gotten almost to where Kure Atoll is. The Hawaiian chain that you see here from Kauai to the Big Island is just a small part of the Hawaiian island chain. It actually extends 3 times farther out here to Kure Atoll, which is now the Northwest Hawaiian Islands National Monument. It was declared a national monument during the term of President Bush, and it has become the longest in extent of any sea protected area. Now after a year, again you can see the same thing happening. The debris being caught in the Kurashiro extension, the Japanese current flowing to the east, whereas our debris is coming down here to the west and wouldn't be seen by someone in the eastern garbage patch. After 3 years, you can see the eastern garbage patch beginning to form, but it's all red. All the Japanese stuff is what's constituting it. And after just 3 years, you may still see markings, say for instance on a cigarette lighter or a jug or a bottle. You would be able to see some identifiable markings, whereas our stuff still is decaying, heading over here. And after 10 years, you've got a couple of our pieces back here, but by 10 years, it's probably going to be chips. It's not going to be a full big object where you can read the label. But after 10 years, you start to see the western garbage patch forming with our stuff principally. So it's kind of a trade-off. We're polluting the Philippines and Vietnam and southern Japanese islands, whereas Japan is polluting not so much our shores, but the area between Hawaii and the United States. Then after 20 years, you see this North Pacific subtropical gyre, this convergent zone, and you can kind of see the NOAA depiction is rather narrower, but you can see this area of concentration of debris here. Now in 1989, Dr. Day did some sampling over here and found 300,000 pieces per square kilometer of plastic in the western side of the North Pacific gyre. And 10 years later, we did our sampling and found 900,000 pieces per square kilometer in the eastern North Pacific gyre. So we found triple what he had found 10 years earlier. Now I'm going to go ahead and back out of this and play a, and it's hard to see up here right now. Got to minimize this and find the 30-year Japan drift. Okay, right there. Okay, there we go. Now this is really great. This the reason we're backing out of this to show you this particular animation is because it shows how difficult it is to really show the, let's see, we want this, is this it here? Yeah. Okay, and that was Control F, am I right? Yeah, and then we're going to, come on. There we are. Now, before I play this thing, let me give you a little explanation of it. You can see he's got boxes here to count the number of pieces in the eastern garbage patch, the number of pieces in the western garbage patch. And what you're going to see is the movement of those pieces, if it'll do it for me. Let's see. A little. And people want to know, well, where is this place? Let's go clean it up. Let's find all this trash out there. Now, if it'll just, come on, do it. Okay, I got it. I can't. There we go. Okay. Well, yeah. I mean, this count is going, this is a 30-year time series with trash being released every 10 days, okay? So after 15 years, we're down here in the hundreds. This is like 200, you know. Now this is 200, this is 200, this is 120, but it's going up, it's going down, it's going all around. Oh, and there's a bunch of stuff up there in the Gulf of Alaska. Oh, and there's a bunch of stuff up there in the Bering Sea. Oh, and there's some stuff down here in the Intertropical Convergence Zone and heading over to Asia. So what are you going to say when people ask you, where is it all? Where's the garbage? Where do we go to get it? Where is it? You know, it's not a simple question to answer. I'll do that again. There it is, starting from Japan, and you can see it's just a very variable phenomenon. We found higher levels outside the eastern garbage patch than we found in it, and you'll see that here on occasion in this simulation. So this is a mobile system, folks. This is liquid. This is the ocean. This is impacted by storms. This is impacted by hurricanes. This is impacted by wave action. It's impacted by a number of different forces, and it's not going to be a simple matter to determine where this stuff is going. Okay, now I gotta try and get back to the PowerPoint. All right. Okay. So you can kind of see, anyway, where our research has taken place has been, this is 2/3 of the way to Japan. This is the international date line right here, 180 degrees longitude. And our samples have comprised about 2/3 of that area where those drifters were being diagrammed. So what is it that we find when we trawl our nets through there? Well, this is what we find. This is like a 1 mile trawl, one of those times that we deployed that net, took off that bag, dumped the stuff out of there. These areas that we're doing this are about as far from human civilization as you can get anywhere on Earth. The most isolated island system in the world is the Hawaiian Archipelago. And halfway between the Hawaiian Archipelago and the mainland is the most distant place from civilization anywhere on Earth. And yet our plastic footprint is abundant. And to drive this home, I'm just going to show you over the whole time frame that we've collected these samples, examples of what we found. Now, not every sample is going to be chock-a-block full of plastic. Here's one that's principally got bits of strapping from pallet wrap and the blue plastic tarps that you're deploying on your coastal hillsides to prevent erosion. That's the unweaving of those blue plastic tarps, that blue filament there. But overwhelmingly what we find are samples like this. Those ones that are light are typically closer to the coast. There's some areas where NOAA scientists have sampled and not found plastic off our coast. The cow coffee stations. I recently reviewed a paper for Miriam Doyle, and the cow coffee stations off our coast had some trawls come back without plastic in them. because we have the westerly winds pushing the stuff back on shore, and the stuff that is getting caught is flowing a little lower and out and not showing up in the trawls. But once you get past, say, 200 miles from the coast, your samples start looking like this. There's one of those funny looking forks that, you know, we don't recognize as coming from a McDonald's or a Burger King, but did come from a fast food restaurant, but probably one in Japan or China. Here is a sheath for a knife, a plastic sheath, a handle for a bucket, toothbrush. But overwhelmingly, you see it's this broken down bits of plastic that are just persisting in the ocean. Here again, another toothbrush. This is the thicker parts of the bottle are the neck and the cap. And there you can see the whole bottle has eroded away, and all that's left is the cap and the neck of the bottle. That's the process of photodegradation, where ultraviolet rays of the sun have broken down the plastic and gone with the thinnest parts first. This purple color is due to the amphipods and copepods, the shrimp-like creatures that are in the trawls, the zooplankton, which we compare the weight to when we do our sample analysis. These round jellies here are related to the Velella velella. They're a button Velella colonial jellyfish, but more plastic than plankton is what you're seeing in these pictures. And just the kind of disgust and despair, really, that we feel when we see this coming in over a beautiful, pristine blue ocean surface. If you look horizontally out over it, not down into it, you just see blue water. But if you look down into it, you begin to see these particles. And it's just sad that over really what amounts to hundreds of thousands and millions of square miles of ocean, you can drop a net in like the one that I showed and obtain a sample that looks like this. It's just disgusting. That's a spacer from the oyster aquaculture operations that separate the oysters. Probably the most common item that I see just observing out there is the bottle cap. And that's the reason why we're supporting the leash law in California that would require, in the same way that we ended up requiring beer and soda can manufacturers to keep the pop top on the can, we'd like to see the caps kept on the bottles. They're being consumed, and you'll see by whom later in the presentation. Again, you may not recognize anything in this, but it's all post-consumer and pre-production plastic pellets. Post-consumer waste, another oyster spacer, popsicle stick. We get lots of these washing up on the beaches in Hawaii. We went from wood popsicle sticks to plastic. And just junk. That's one of the worst we ever found. And that was outside the garbage patch. It was about 800 miles north of Kauai. And that was outside the garbage patch, just about 30 degrees north after leaving Hawaii on the Esperanza, another vessel I guided to this area. And this is a night sample. And what we catch at night is a lot of night-feeding myctophids, the lanternfish. These little fish are like the anchovies of the deep ocean. They actually outweigh all the other fish in the ocean combined. The various species of myctophidae are over 50% of the ocean's fish biomass. When we separate that sample out, these are the lanterns. You can kind of see they have these little photophores on the side. That's why they're called lanternfish. They have glowing apparatus on them, and they spend the daylight hours. The reason they're so successful and represent over 50% of the fish biomass is that they are very successful in hiding from predators, and they do that by remaining in the darkness. They feed only at night when it's dark near the surface, and then as soon as it begins to dawn, they head straight back down, maybe even a mile deep, to hide during the day, and then come back and repeat that process again the next night. Now, when we take those samples back to our laboratory, we put them in petri dishes and take forceps and a dissecting microscope and separate out the plastic from the plankton. Once we've separated out the plastic from the plankton, we put it through a series of Tyler sieves, which are the same kind of sieves that geologists use to measure sediment grain size. And so this would be 4 millimeters to 2 millimeters, 1 to 2 millimeters, 3/4 to 1 millimeter, half to 3/4, and 1/3 of a millimeter to 1/2 of a millimeter. And there's a bit of a question here as to why this stuff is disappearing, why we're not seeing more of it. I mean, after all, if you crumble up a cookie, you get a lot of crumbs. One cookie makes many cookie crumbs. So you think of these as cookies, you crumble them up, you should be getting a corresponding number of crumbs out of the ocean, but we don't. And we'll talk a little bit later about why that might be. In the ocean, nothing ever stays the same. It's never calm for very long, and the wind blows up, and it gets a little too rough for us to sample, and that's when the albatross doesn't even have to flap its wings. This bird will glide for days with its wings just locked in position over the surface of the ocean, and this wind blowing over the ocean is creating forces that are moving the ocean in undersea currents as well as surface currents. And they're making cylindrical units called Langmuir cells. Sometimes you hear it referred to Ekman spirals. These are kind of currents that are rotating under the force of the wind blowing over the surface of the ocean. And what they'll do is they'll kind of dredge. When you get them counter-rotating, one's pushing past the other and they're dredging stuff up from the bottom, and then you can see after it calms down again, they'll leave a line of debris on the surface. This is the detritus from a bloom of plankton. The motion of those cells brings nutrients, which causes blooms of plankton, but it also at the same time brings up trash. And what we found is that the less dense stuff, like the planktonic organism leftovers, is sort of in the middle of these windrows, these rivers of calm in the ocean. And on the edges, and you can see us kind of navigating along the edge here, that's because that's where we find the trash. Like in a afternoon of pulling up junk from the ocean, this would be our catch. This from one of those windrows out in the Central Pacific. Windrow being a river of calm caused by winds that have blown over the ocean and then dredged up stuff and left it on the surface for us to find. There is more than one day's collection, but we put it all together. Actually, there was a rumor, I think Stephanie started, that we were going to be in People magazine and that they needed a picture that would be appropriate. And so this was a People magazine pose using a hard hat here. There's a lot of safety equipment being used on board ships now, but it's inexpensive and disposable evidently, because we're finding a lot of hard hats, a lot of crates, neon light tube, but never got to use it for People magazine, but I think it's a great shot, and it's showing a lot of the junk that we find out there in the middle of the gyre. Now, it turns out that there's not just one of these high pressure gyres, there's 5 of them. And so my colleague Dr. Marcus Erickson and his wife Anna Cummins have begun a project called the 5 Gyres, and they actually have now been to 3 of the 5. They've been with me to the North Pacific. They've been with Pangea Explorations to the North Atlantic, and they just went with the recreation of the voyage of the Beagle, a Dutch group, through the Indian Ocean gyre here. Went from Perth to Mauritius over here on the edge of the Indian Ocean gyre. Turns out all of them are full of plastic. I mean, that's the North Atlantic gyre. People often ask, why can't you see it from space? Well, it's typically floating a little bit below the surface, but I mean, this would be easily visible from a low-flying aircraft. It wouldn't be visible from a typical passenger jet flying at 30,000 feet plus, but you would be able to see it from an aircraft flying 500 to a few thousand feet above the ocean. They can see these things and spot them very readily. But this is the kind of stuff you saw in those samples, but it's in the North Atlantic and what's known as the Sargasso Sea area, which is the North Atlantic garbage patch, North Atlantic subtropical gyre. Now, again, keep in mind where these are, where these 5 accumulators of our debris are when you look at this map. This map is of the exclusive economic zones of the world. This is countries, in order to manage their resources, have enacted a system in which they control the resources within 200 miles of their shore, so that there's an economic interest there. They have control of it. Small nations like Micronesia that have a lot of little islands but extending out 200 miles from their coast can sell like tuna rights and stuff like that and make a lot of money selling the rights to fish in those areas. But if you look back and think, well, wait a minute now, let's look and see what the heck, this doesn't belong to anybody. 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 Nobody owns rights to these garbage patches. They are free. You can go harvest those garbage patches and you don't have to pay anybody. Not that that would be a way to get rid of it, but it's also not a motivator for any nation to own the problem. It's truly a matter for the United Nations. It's a tragedy of the commons. It's the heritage of every man, woman, and child on earth. These areas belong to them, and we're trashing them. And so it's going to be up, and it's truly everyone's plastic footprint that's doing it, so it's going to be up to everyone to fix it, to deal with it. It's not going to be the work of any particular nation. Again, looking at those samples and thinking, where is that going? Well, we think filter feeders. That's where it's going. This is little microscopic salps. Salps are the vacuum cleaners of the ocean. They are just a cylinder with musculature. They're actually chordate jellies, so they're distantly related to us. We're chordate animals. They have a spinal cord, rudimentary, and they're capable of filtering half the water column they inhabit every day. So anything that will fit in this opening is going to be sucked in. And there is what we think is happening to those smaller pieces. These animals don't feed in the way that we think of normally eating, by seeing what they eat and tasting it and taking it into their body based on some tactile sensation. They're just simply impacting what's ever out there. That's a good strategy in the middle of the ocean where we don't find any insects, we don't find any kelp, we don't find any wood really, unless it's a big log. Everything is already biodegraded by the time it's got out there. So just about anything that they would be historically, evolutionarily impacting would be edible. It would be something that was food for them. Unfortunately, it's happening to charismatic animals too. In fact, and we'll talk about this quite a bit, it's happening to every single trophic level, every single feeding stage in the ocean. This is an animal that was killed not by blocking its throat so it couldn't eat more, but it was blocking its pylorus. It couldn't eliminate the food that it had eaten, so it died. This is a Ziploc baggie that has obviously been sampled by probably triggerfish, by who knows what, birds. Anyway, it's being shredded. It just feels like food. It looks and tastes and feels and has the characteristics of something that might be edible, like maybe we often find leftovers of bits of squid. Whales and squid, as we know, have this thing going on in the deep ocean, and a whale may be able to get a bite of a squid and leave a big hunk of it, and we'll see big hunks of big, thick squid tissue from giant squid. We'll see them floating on the surface. That would be something that would have the texture and feel of a baggie to a creature. Here's an example of plastic becoming part of an animal without even having been eaten. These are Velella, the by-the-wind sailor, the jellyfish that has the little sail that sails around the ocean. And this just happened to bump into it. They're sticky, gooey creatures, and when the plastic touches them, it sticks to them, and then they just begin growing tissue over it. So without truly ingesting it, it's just become part of their body. And here we have something that we would expect to find here in Orange County in the tide pools. These are sea anemones. There they are underwater. The previous slide showed them out of the water, living on a piece of plastic, which is simulating a rock in the intertidal zone. So what we're creating here, out in the middle of the ocean, is a rocky intertidal habitat for sea anemones who are using what would be shell and pieces of sand decorating their bodies. Now we're finding pieces of plastic taking that, and it's likely Dr. Andrea Neal up at the Bren School in UC Santa Barbara believes that this is just the tip of the iceberg. What these tentacles are doing is taking in microscopic pieces of plastic that are floating around out there as well. This is the field that we want to explore next with our research, is the submicroscopic level of ingestion of plastic in the ocean. We believe that filler feeders are getting the individual polymer molecules ingested. Getting back to the fish, those myctophids that we talked about, we actually collected 671 of these guys. We've got the paper now submitted to Marine Pollution Bulletin analyzing the stomach contents. Christiana Borger, our ichthyologist, works at Carrillo Marine Aquarium, took and each one of these pickled fish, she opened up the stomach, which is right here, made a slit in it, and there you can see a single piece of plastic inside the stomach of one of those myctophids. Here again, the same sort of problem that the turtle had. The mouth can take in something bigger than the anus can expel. So you've got this piece of plastic here. That was a single piece that broke when we took it out. But you could see it could go in, but it would never come out. And this is the natural food, and this is the plastic. And then continuing the analysis, we're starting to find about equal parts natural food and plastic. And when I mentioned the fact that it's post-consumer except for the pre-production plastic pellets, this is one of the pre-production plastic. You can tell them by their oval shape. They're pretty easily identifiable. This is the feedstock of the thermoplastic industry. All plastics that are melted and made into objects, whether it's a bag or a bottle or some other object, begin their life as these pellets. This is the most economical way for plastic companies to produce a solid, and plastic is the solid phase of petroleum. They take the petroleum, make a solid out of it through catalyzation and polymerization, take that solid and put it into this pellet form. Then they just blow it into a rail car. When it gets to the factory, the rail car is attached to a hose, a vacuum hose that sucks these pellets out. When they make and break that connection to the rail car, these pellets spill onto the railroad tracks, and when it rains, they wash down through the storm drain system into the ocean, so that we found 10% in the remote beaches of the Hawaiian Islands of the plastic fragments were pre-production plastic pellets. And right here in Orange County, there's a tremendous load of those, and I'll talk about that a little later, because we have more plastic processing factories in the three-county area here than any place west of the Mississippi. Now, this is the record holder. This little fish, these Myctophidae, they're as big as your finger. They're anchovies of the deep ocean. As I say, they outnumber all the anchovies, herring, sardines, smelt, menhaden, mackerel, put together. All of them put together, all the fish put together weigh less than the genus Myctophidae, and we're filling up that genus. It's accident prone. Its lifestyle lends it the probability that it will be ingesting surface floating plastics because it's feeding frantically, in the dark, in a hurry, got to get a lot of energy going on, then dive down a mile below the surface. Well, these are little flotation devices. These are little life jackets inside that fish. They're fighting against it as it's trying to go down. They're lighter than water. They've been floating at the surface. So this gives it no nutrition, no energy to make that descent. This is probably going to result in less reproductive capacity. There's very real possibility that we could see a crash in the numbers of the most numerous fish in the ocean feeding all the other deep ocean fishes because of our trash. Now, the poster child for plastic ingestion in the marine environment is the Laysan Albatross. They nest by the millions on the Hawaiian archipelago, the northwest Hawaiian island chain, and they're big birds. They're as big as condors. This is a 4-month-old chick, and you can see the stomach on this 4-month-old chick is as big as the stomach of this biologist. I mean, this is a big chick. And 4 months old, what you want to see is a stomach full of squid beaks and eyes, which is this natural part down here. But what we're actually finding is jar lids from Japanese menes with little Kewpie dolls on it. That Kewpie menes is very popular in Japan. Finding lighters, fishing lures, bottle caps, and foam. This is natural pumice from a volcanic eruption, but this is foam insulation like the kind you might spray in a wall, something of that nature. And it's not just a few of these birds that are affected. It's hundreds of thousands of them dying every year with stomachs that look like this. This is sad. This is unintended consequence of our profligate waste. Bottle caps especially, big problem. But toothbrushes, cigarette lighters. This bird is famous for a reason that I'll explain. It's hanging on the wall, this photo in the National Oceanographic and Atmospheric Administration Marine Debris Headquarters office in Honolulu area. And the reason that the stomach contents of that particular albatross are famous is because I think it was this piece here had a number on it which identified it as part of a World War II aircraft. And therefore it holds the record for being the oldest identifiable piece of plastic in an animal, or in a sample for that matter, from the ocean. And shows you that after half a century it's very little decomposed. That's why our pamphlet says plastic like diamonds are forever. It's just no good estimate of how long this stuff will last. We don't, it's all guesses. You might see a poster at some Earth Day event that'll say so long for a six-pack ring, how long for a plastic bag. It's all total guesswork. There's absolutely no data, because why? Plastic's only been around for 75 years. We don't have the kind of data that would help us understand how long it lasts in the environment. The ocean's a cool place. It's not full of what Dr. Rowley would call the FBI, the fungus, bacteria, and insects that break things down in a compost pile. A compost pile is hot, 140 degrees. Maybe in soil you'll get 1% to 2% a year, or in a compost pile a little more out of biodegradation of petroleum-based plastics. But in the ocean, you don't get those hot temperatures. There's very little fungi in the ocean. There's only one insect, the halobates, a water strider on the surface. You don't have this boiling hot, intense biological activity going on out in the ocean. So things like plastics last a lot longer in the ocean. Here we have the bird on this poster. It says, "Plastic pollution kills." Linda Lundell, an artist, went to the Museum of Natural History and got a beak of a Laysan albatross to put on there to simulate where the beak belonged when she made that poster, but it's unretouched. This is the natural bird, and this is the poster. It's not retouched in the sense that's when we first put that poster out, everybody thought it was photoshopped, but you know, it's not. Now, this just happened 2 days ago. I got this information. This is really bothering me. This is the opposite end of the trophic level spectrum. From the little salps that I showed you, this is our whale. This is the California gray whale. This beautiful young California gray whale washed up on a West Seattle beach with 50 gallons of material in its stomach. Most was algae, but there were a pair of sweatpants, a golf ball, 20 plastic bags, small towels, surgical gloves, plastic pieces, and duct tape. Now, why does that bother me? This whale doesn't eat animals that are large. It sucks tiny shrimps out of the ocean, the krill, with its baleen. This is a mystocetes whale. This is not a humpback or not a sperm whale, a kind of whale that has big teeth that is going to fight with a squid. This is a filter feeding whale that lives on tiny marine organisms. It sluices tremendous amounts of water. What it means is that junk that's in that whale was mixed in with planktonic organisms in the water. Dr. Heining, who was with the Museum of Natural History, told me a decade ago when we got a permit to do a necropsy on a gray whale in Scammons Lagoon that he had never seen a mystocetes whale, a baleen whale, with plastic in its stomach. He'd done many necropsies. So in the decade, and Dr. Heining since passed away, but in that decade, from the time he'd never seen that, we're now seeing the top of the marine food web, the filter feeding whales succumbing with plastic of many different descriptions in their stomach. And it's scary because these are coastal whales. These whales migrate along our coast. That's why the whale watching industry can make a lot of money, because you go a few miles offshore and you're going to see these guys, thousands of them migrating from the bays of Baja California up to Alaska. The fact now that we have fouled the ocean to the extent that their attempt to feed on tiny marine crustaceans is leading to their ingesting our underwear and our towels. I mean, I've dived on the reefs of Hawaii off the tourist beaches, and I've been alarmed to find underwear on the coral. Tourists from the Midwest they used to lakes. They don't know that the tide comes in. They put their towel down, they go for a walk, the tide comes in, it goes out. You go out on the reefs outside these tourist beaches, you find all this swimming gear. Now it's made its way to the whales. I mean, are we going to have an underwear railroad from the beaches of California to the beaches of Hawaii? Very scary. This is very scary. Now it's the whole marine ecosystem now is on a plastic diet. What does that mean? This is not digestible. This is not nutritive. It's choking the natural environment in the ocean. Not only are we creating this waste, we're also using the waste to transport exotic species. I mentioned the fact that we had a rocky intertidal habitat out in the middle of the ocean now. Well, guess what? We also have coral reefs out in the middle of the ocean now. This is coral growing on a broken plastic fishing float. These are pieces of coral that have grown up in the North Pacific. And, you know, fish that may follow these pieces of debris around are having the kind of habitat they need to survive. This is a very good medium for bringing exotic species. I mean, in the Central Pacific and the tropical waters, you don't expect to find mussels, but this is the mitolus edulus, the edible mussel that we had at dinner tonight at the Japanese restaurant over here, out in the middle of the ocean in a habitat where it doesn't belong. So when we talk about, say, for instance, ballast water and the movement to sterilize ballast water from ships, ship is moving at 500 miles a day. It's be a big shock when it pumps out that water into a new habitat. Those organisms are not going to have the same salinity, temperature, and dissolved oxygen they had in their former habitat. But these organisms that are floating 10 miles a day on ocean currents are able to create new generations of themselves acclimated to their new habitat. That's why as we open up the Arctic regions now with warmer temperatures, these organisms are going to be able to populate there. And the consequences of that are alarming. I mean, we're going to get things like these polychaete worms becoming giant this is a huge worm that we found that never would have grown to that size if it hadn't had this substrate to exist on. And it doesn't have to be a big thing. It can be a tiny little piece of styrofoam, no larger than this little pre-production plastic pellet, which, as you can see, is about 5 millimeters in diameter, already being habitat for all these barnacles. A study was done in England showing that barnacles had migrated north to English shores from southern parts of the Atlantic. Here's a packing peanut with larval barnacles on it, you know, those styrofoam peanuts. Here's a piece of rope with eggs laid on it. Here's a plastic shard with eggs laid on it. And the consequence of, you know, plastics are very good at inhabiting the entire water column. Let's just talk for a second about styrofoam. It's expanded polystyrene. Actually, polystyrene is heavier than water. Your CD case will sink. We find them on the bottom. But if you blow air into that and make it foamed polystyrene, like the kind of stuff you find in your ice coolers, that material will float. But it degrades in the ocean, erodes away, and then sinks. So that it's likely that foamed polystyrene in various stages of degradation populates the entire water column. So it's true that total biotic mixing, meaning the transportation of species throughout the water column that normally wouldn't make it there, can be accomplished through the substrate of plastic moving stuff around. Scientists estimate we'll lose 47%. That's about half of our marine species will be lost. In the same way you can think about it as European weeds in the vacant lots here around the college. You won't find typical California species popping out of the ground in a cleared area. You'll find broadleaf plantain, you'll find brome grasses, you'll find things that have outcompeted our native species that were brought by European settlers. This is the kind of thing that's happening now in the ocean. We're populating the ocean with exotic species on our trash. I mean, this Star Wars contraption here is nothing but a black plastic trash bag. And you see, these fish follow that because it protects them. They can hide there from predators. These are condos for these fish. We're finding now that the fish are growing up inside here and then can't get out through the neck. Dr. Erickson brought one up in the North Atlantic gyre that had a triggerfish inside that couldn't get out. They shook and shook and shook. The bottle wouldn't come out. They ended up having to cut it out and release it because it had grown to maturity inside and couldn't get out through the neck of the bottle. And talk about a bucket of fish. I mean, here's a crate of fish. And you'd think, you know, as you approach these rainbow runner inside this crate that they'd try to jump out or move away. Not at all. If you pull that thing down, they swim as fast as they can. This is not their prison. This is their refuge. This is their church. This is where they go to hide from predators. So once we pulled that thing out, all those fish came up with it. They didn't want to leave there. We can't get them to leave. They're stuck inside. So they're very much drawn to this debris. And people ask me, what's the weirdest thing you've seen out there? Well, this is a washlet. It's a Japanese bidet, econo bidet, has little tubes in it. You can see it's kind of hollow there that, you know, if you've been to Japan, you may have been able to use one of these. These allow you to select water temperature and flow rate for toilet paper substitute, which is a nice idea, but we don't need them out in the middle of the ocean. So if we could go ahead now, I don't know that I have the ability to do this, but we've been working with Bill McDonald, who formerly was with the Cousteau Society, to kind of bring these facts to the general public, and he's been very good at creating short video pieces, DVDs, that can do this.
Humans have long been drawn to the sea. The ocean is a magnet for those wishing to explore the most incredible realm on planet Earth, rich with beauty, wonder, and adventure. Humans love to be in, on, or just inside of the sea. But the human-ocean relationship is bittersweet. For centuries, the oceans have been used as a dump for human debris. Since the 1960s, post-consumer plastic products have become the most common and persistent pollutants in the world's oceans. Plastics are lightweight, durable, and cost-effective. Plastics can be fabricated into almost anything. Lamentably, these same properties pose a serious hazard to ecosystems. It has been said that plastics, like diamonds, are forever. Plastics are scientifically proven to absorb pollutants like DDT and PCBs up to 1 million times the concentration in surrounding waters, creating toxic synthetic drifters. As it breaks down, plastic trash can be confused for food by sea creatures due to its size, shape, and color. Since plastic chips on Hawaiian shorelines are mostly blue, black, and clear chips, researchers believe that much of the red and yellow particles have been eaten by fish, birds, and turtles, thus contaminating the ocean's food chain. Consuming toxic plastic is believed to create endocrine disruption that impacts gender, whereby males become more feminine and cannot produce sperm. Plastic floating at or near the surface is part of a drifting surface ecosystem called a windrow. Here you can make out concentrations of zooplankton, drifting jellies and ctenophores mixing with marine debris and plastic chips. You can see herring schools feeding and observe how the drifting debris zones attract all manner of foragers. Over the eons of millennia, foraging sea creatures have been using these windrows for nutrition, but now these debris zones contain toxic accumulations of plastic. Due to the long life of polymers in the marine environment, it is vital that humans address the litter problem locally, nationally, and internationally.
It's a truly disgusting plastic cesspool that has to be burned into the consciousness of humanity that the ocean is now a plastic wasteland. This octopus takes this plastic shower head with it as protection. It's like the fish, like the other crates and stuff. So the fish wouldn't be able to drag the stuff with them, but the octopus is smarter. Okay. Now, I said that I wouldn't go back out there last time I came in because I feared for the safety of the crew and the ship. And I stick to that. Without modifications to the vessel, I won't go back out there. It's just too dangerous. I had to dive over in the middle of the night and cut these kind of nets off our prop. They jammed the drive shaft up into the cover for the belts for the hydraulic system, made this horrible grinding noise. We thought we'd thrown a rod in the middle of the night. I mean, just cutting this stuff off time after time. I mean, it didn't happen just once or twice. It happened several times. It's just too dangerous. We got a bunch of holes in the boat. We don't know what we hit. This is the Canadian Coast Guard. They actually emailed us saying, please tell us where all the nets are out here. We don't want to hit any more of them. You know, we're running across the North Pacific and we're running into all these nets. Can you imagine a diver down the Coast Guard having to deploy a rescue diver that should be involved in saving lives just to get that off of their propeller so they continue their voyage? Millions and millions of dollars in damages are done by these derelict fishing nets, which are now so cheap and deployed by so much subsidized government fishing that they're being lost all over the place, and they're just a huge problem in the Northwest Hawaiian Islands. That's what our government is focused on. The National Oceanographic Administration Marine Debris Program focuses exclusively on ghost nets, these big nets, because they're causing so much harm in the Northwest Hawaiian Islands, killing our most endangered mammal, the Hawaiian monk seal. We bumped into this wire spool after the wire had been taken off. It got chucked overboard. We think it was from a Chilean vessel because when we pulled it up, it had six-pack covers from Chilean beer inside the middle of it. This, we don't know what it was. I mean, I don't know if that's like a tip of an iceberg and there's something solid underneath that. I don't want to hit it in the middle of the night. So how did we get to this situation? Let's talk a little bit about the history of our society. You know, really, a single serving container wasn't a common thing before World War II. Beer came in kegs. If you wanted a piece of pie, you went into a restaurant and they cut you a piece of pie off of a pie. You didn't go and get a single serving. And during World War II, we'd come out of the Great Depression. We knew we needed the aluminum for planes. We needed the steel for tanks. We needed rubber for vehicles. You just wouldn't have seen this kind of behavior. This was after the war that this happened. If you'd have gone into a post office during World War II, you'd have seen a poster like this. And I want to highlight, this victory poster's really ethical standards that are just now beginning to come back. Raise and share food, walk and carry packages, conserve everything you have. This ethical standard, this ethos of our society, has only been abridged for half a century. Half a century ago, we didn't have this throwaway culture. But at the end of the war, we had tremendous productive capacity. We won one, We had huge factories that had the Rosie, the Riveter, the women were working. We had a tremendous productive capacity. How to not lose that employment, how to keep it going after we didn't need this war material? Well, I think, and I don't claim a conspiracy here, it's just a logical outgrowth of wanting to keep full employment after the war, that you would want to have planned obsolescence. You want things to break so that you could make new ones. You'd want things you throw away so that you could make new ones. I mean, the theory of this article, in 1955, we didn't get our information from Good Morning America and Oprah. Everyone didn't have a TV in their home. The national magazines were the way in which ethical standards were communicated. And Life magazine had this article called Throwaway Living, and the thesis was that the woman could be this is a women's lib poster from 1955. I mean, why feel guilty, It saves time, go for convenience, use once and toss. And the first throwaways were aluminum. Remember those TV dinners that went on the special TV trays that had the really lousy mashed potatoes and the nasty green beans and the chicken that tasted like aluminum? That was not so bad when it was paper and aluminum, but now throwaways are mostly plastic, and we just don't do a good job recovering plastic. We do a good job with paper, we do a good job with aluminum, we do a good job with steel, we do a good job with glass, but this is diddly point squat. I mean, we don't recover any plastic to speak of. It's just not enough to make a difference. And I think the reason is because plastic's not purified in the remelting process. Plastic is beginning to form a new product at about the boiling point of water. It doesn't drive off the contaminants, doesn't vaporize the paints that are on it, doesn't vaporize the oils that are stuck to it. Plastic is lipophilic, oil-loving, very hard to clean, and you get rid of all that stuff when you melt steel, glass, and aluminum at these high temperatures. But plastic, you're actually forbidden to use in a food contact application if it's recycled plastic, because it hasn't become clean in the recycling process. So what do? We downcycle it. We use it for plastic wood. But plastic wood has another problem in the fact here in Kalu'u, which is a famous tourist beach in the Big Island where people go to see the beautiful tropical fish, keep the tourists from cutting their feet on the sharp coral sand, the County of Hawaii decided to put in Trex, which is plastic lumber. Well, they didn't realize there's another property of plastic, and that is its thermal loading. It becomes hotter than the surrounding atmosphere, so that in that hot tropical sun, it got to that point where it started to melt, where it started to warp, where it started to buckle. And not only that, so now if you go back there, this is cement. They had a total waste of money. And here on the picnic benches there, you see wherever it's not supported, it doesn't have these long fibers that wood has that allow it to bend without breaking. It just snaps off where it's not supported. I mean, this was a picnic table where Sam and I stopped for lunch in Central California on our way up to speak with Stephanie at the Recology waste haulers meeting up there. And just why are you going to bother to cover something in recycled plastic if the only place that you can put it is on a support? Why not just make the table out of whatever strong thing it is that's going to support the plastic and forget the plastic? I mean, it's breaking off. We couldn't sit on the bench. It was totally unusable, just not a functional way to use recycled plastic. So we're having a lot of problems figuring out what to do with recycled plastic. So you take something that's fast-track trash, that doesn't have a good recycling infrastructure, and is lightweight and covers everything, and this is what you see after a rain. This is where I live, near Cal State University, Long Beach, and really we wanted to know how much is getting out into the ocean. So we got the California Integrated, actually the California State Water Resources Control Board sponsored a study of the Los Angeles and San Gabriel rivers determining how much plastic came out there. And what we did was we looked at what we call the mass emission points, the area where all the tributaries have come in, but there's no tidal influence. So you're getting everything that's going to the ocean without the ocean giving you anything back. And we used the same kind of nets we used out in the ocean. There's low flow down in Coyote Creek, and low flow. We also used a stream bed sampler so we could get a sample from right on the bottom. And we used this because plastic is hydrophobic, meaning it's water fearing. It's actually almost like it's trying to climb out. You find a lot more plastic a lot of times along the edge of the river. So we had a hand net that we put right along the edge of the river to sample that. So we had several different kinds of nets, and the low flow, and then the high flow we had to drop a net, a weighted net off of the bridge, and in addition to doing the one along the side, and pull it through the water column over to the side of the river. Summing up the results, in 3 days, one rainy day like today, light rain, another rainy day, heavy, and a third dry day, low flow, we found 2.3 billion pieces of plastic weighing 30 metric tons in just 3 days in those two rivers draining into San Pedro Bay. And we didn't even count Ballona Creek. This is the creek that drains into Santa Monica Bay that drains central Los Angeles. That wasn't part of the study. But is it a phenomenon only associated with rich industrialized countries like ours? No. This is Mumbai, India. This is Lagos, Nigeria. Looks just about like Ballona Creek. And now, of course, with China coming online, all those fears that are projected by those who imagine the kind of horrible conduct vis-a-vis the environment that we exhibited in our industrialization is now being repeated by an even greater population with exceedingly bad results. And just to show you, this I think is fascinating. I was being interviewed by an Italian writer who wanted to write a book on my work, and his previous project was a study of the Somali pirates. And he actually went to the Somali pirate village, and I'm thinking, if you want to find a population that's kind of by force not going to be having a lot of communication with centers of civilization, it would probably be the Somali pirates. And yet their village looks like, you know, a landfill of plastic. So it doesn't really matter. Rich, poor, isolated, or the center of civilization, plastic pollution is going great guns into the ocean. And I put this in because these are the victims. The Hawaiians do not generate this trash. This is less than 1% generated in the Hawaiian archipelago. They are the victims of the trash from the Pacific Rim that is coming from all the industrialized nations surrounding them. That's what's ending up on their beach. Previously, they went to this beach in order to get logs from the Pacific Northwest to build their canoes. This is a collector beach. This was known to the ancient Hawaiians. They went there to retrieve bodies that had washed overboard, because that was a tendency where they would wash up. They went there to find these logs that were of a different kind of wood than grew on the islands that would give them the potential to create different kinds of canoes, do different kind of work with their stone adzes. So this has been known since ancient times, but instead of this washing up there, now this is what we're finding there. So, I mean, think about it. I showed you the crates like this that were out in the middle. I showed you the crates coming up. I mean, here's one of them. I mean, it doesn't take a rocket scientist to imagine that we have this trail now of debris from civilization to the most remote parts of the ocean that's like a continuous road. It's like a conveyor belt. We have this conveyor belt of trash going into the ocean. And that's what's finally now impacting the greatest of all the marine creatures, the great whales. This is our baby. This is our gray whale. This is the one we saved from extinction. This is the one Mexico, our neighbor to the south, declared the first truly endangered species that took action, created the first environmental laws to protect a major species, was done in Mexico. And we stopped Mitsubishi from building a salt plant that would have disturbed their calving grounds in San Ignacio Lagoon. And now we're killing them with our underwear. Sick. That's sick. So how much is out there? This is 100 million metric tons, I think, is very conservative. People have estimated recently that we're losing 10% to the ocean every year, and that we're doing about 250 million tons a year. That means in 4 years, if I'm right, I mean, I thought I was being very conservative here, since the dawn of the plastic era, 100 million tons, 2.5% of world production. But estimates are being made that would double that figure in 4 years. I think they're high, but those estimates are out there, published. 10%, 250 million tons a year. So what are the human health effects? What are we looking at here? I mean, I'm still going into doctors' offices and seeing these guys, you know. Number 7 plastic, polycarbonate plastic, leaches bisphenol A. When Sparklets and Arrowhead took away the glass bottles and put plastic in, I was suspicious, but I was reassured. I mean, I had home water delivery service in these bottles for many years, not realizing that I was dosing myself with bisphenol A. Bisphenol A is in the polycarbonate number 7 plastics. It's in the hard Nalgene sports bottles. It's in the epoxies that line the canned food. It's in the clear baby bottles and in these Sparklets bottles. Significant doses? Yes. The doses are significant and found in susceptible populations. Pregnant women and fetuses. maternal blood, fetal blood, placenta, everywhere. A baby drinking from a clear plastic bottle will get 5 micrograms per kilogram a day bisphenol A. This is a bioactive dose. Very low level exposure to BPA for just 4 days causes hyperinsulinemia and insulin resistance in adults' mice. Screws up your insulin metabolism. What does that mean? It means that if you give the exact same diet and exercise to 2 mice, the one that's exposed to the bisphenol A chemical will get twice as big, twice as fat. So when Michelle Obama says, let's move and let's get rid of the salt and the fat and the sugar, she's dealing with 2/3 of the problem. The other third is our body burden of industrial chemicals that we didn't have before 1950. All of us have 150 or so industrial chemicals working synergistically to screw up our metabolisms, and no one is able to tell us what that means with any specificity, but we have indications like this. And it's not just in mice, it's also in Japanese women. A study of normal Japanese women and obese Japanese women found that the obese Japanese women had much higher levels of bisphenol A. So showing the levels of bisphenol A in Japanese obese women. So Dr. Bomsal has hypothesized that the exponential increase in man-made chemicals over the last 2 decades is in part responsible for the global epidemic of obesity and diabetes. Significant human health effects from the chemicals in plastics. Another thing, and this again very troubling to me, when I hear about nurturing disappearing among parents, and then find out that in rat studies done by Paolo Palanza in Italy, that exposure to these chemicals takes away this maternal instinct. There's less time retrieving the babies to the nest. And the mother spends more time out of the nest and less time nursing. This is exposed to bisphenol A, less time nursing. Exposed to bisphenol A, more time out of the nest. It takes the women mice, the lady mice, makes them less motherly, and takes the male mice and makes them more motherly. They spend more time on the nest, more time retrieving the babies. How are we getting it besides canned food? Every single supermarket seafood sampled in Singapore had bisphenol A in it. All of our marine resources are contaminated. There's no such thing as organic seafood. Doesn't exist. So, premature breast development, women reaching telearch sooner. Girls are becoming women sooner because of chemicals in plastics. Why aren't we hearing more about it? It's because of manufactured uncertainty. In 2006, Scientific American ran an article called "Doubt is Their Product" about unscrupulous scientists who advertise that they will design a study that will give you the results you desire. So chemical corporations are not paying for a study, they're paying for a result. So every study they do finds no harm from bisphenol A. So you're a legislator, you're a mayor, you're a vice president, you're someone in charge of public policy, you're listening to scientists from the government showing you 138 studies that show harm, and then you've got several studies done by chemical corporations that show no harm, and they're peer-reviewed, and they come to you with the same credentials as the other studies. You find it very difficult to ban a chemical that has this manufactured uncertainty programmed into the debate. And then let's talk about the individuals here, dealing with 700 new products that are introduced every day. 26,893 new food and household products materialized on store shelves throughout the world in 1 year. 2 million brands buy for attention. Are we more than our consumption? or are we simply units of consumption? Is that the meaning of our lives in today's economy? And when you think that these products are all packaged in plastic and that packaging is over 50% of fast-track trash, you realize why we're seeing so much of it in the marine environment. It's a nuisance. Once you unwrap that product, you want the product. Are you going to carry that around with you all day waiting to find a proper receptacle that's not already full of stuff? I mean, this is our legacy. I think you can take the question mark away. Every coastal zone now has this problem, and I just don't want to have to think that these are the recyclers of the future. This, to me, is not what I want to see as a Chinese style of recreation in their coastal zone. And I just put this in because it emphasizes that at our best, we are bad. The ethos that created the throwaway society didn't stop at the space program. This is not talked about much, but during Thanksgiving dinner on the space shuttle, the meal was interrupted by a loud clanking noise, probably something like that ghost net that hit my prop, and it was space debris impacting the space station. Each one of these pieces is got to be tracked if it's over a certain size, or we'd likely be shooting it down thinking it's an incoming missile. But really, you know, plastic rubbish bags were released by the Mir space station during its first 10 years, more than 200 of them. And when there's an explosion up there, it generates bunches of fragments, and 700 among them were big enough to be cataloged. You have to maintain these huge catalogs of them, otherwise you'll think they're enemy missiles coming in. And this stuff is doubling every 5 years. And all the space shuttles come down with pockmarked windows. They're bumping into this stuff like crazy. We already know about the panels getting knocked off. This is not an uncommon problem that we're trashing outer space. We're trashing the universe, folks, and it's being done with a clear conscience. It's absolutely being done with a clear conscience, and this stuff that will orbit the Earth in a stable orbit will live longer than any radioactive pollutant. It'll wait till the sun becomes a supernova and gobbles it up. We're never going to clean this up. We're not going to send the Boy Scouts up there on a Saturday afternoon to do a beach cleanup in outer space or slurp up the chlorofluorocarbons that are causing the ozone hole. So that's not the way we're going to recycle space debris, and this is not the way we should be recycling marine debris. Think about it, because as a species, our plastic footprint is huge. And with that, I'd like to introduce Stephanie Barger of Earth Resource Foundation, founder of the Campaign Against the Plastic Plague, who will talk to you a little bit about what she's doing to campaign against this plague of plastic that's smothering the natural world.
Thank you, Captain Moore. And big round of applause for him and all his incredible work. And just to plug real quickly, they need lots of help getting more funding to go do more research.
And to analyze the samples we already have. We can't even afford to analyze the samples we have.
And analyze samples. So collect all your bottles and cans and send the money to Agalita. Give somebody a Christmas present by giving them a donation. They'll appreciate it. So how are we going to solve all this? Because after this, you know, most people are totally depressed. You're like, why bother? We're done with, you know. So, but we have to do something, and we have to do something immediately, because we have to turn off the plastic faucet now. We can't do it tomorrow. We can't clean this up. And, you know, for Captain Moore and I, you know, we're going to be okay in our 90s and everything. But for you that are under 25, you're basically screwed if we keep going the way that we're going. And it's true. You need to, I mean, in the short time, you know, I've been alive, most of us older people, we didn't have water bottles. We didn't have plastic bags. All these things really came into manufacturing and sale just in the last 15 to 20 years. And most of it's in the last 10 years. And just look all around you. Everything is basically plastic nowadays. We used to have wool carpets and wool clothing and cotton clothing and, canteens and glasses and everything. So with that being said, the solutions are very simple. And it's not about recycling. It's about refusing, rethinking, redesigning, reusing, re-earthing. And Earth Resource, we currently have our Youth Against Styrofoam. And the Green Team Alliance is involved with us. We have the mayor from Laguna Beach here, and Mayor Eisman can talk about the success there with their ban on styrofoam. They're working on plastic bags right now. Newport Beach banned styrofoam. Newport Harbor High School banned styrofoam. There's cities up and down the coast that are banning styrofoam, banning plastic bags, and more importantly, working towards a zero waste community. And I'd love to come back and another time share the solutions on how we get here in more detail. But right now, what you can help us do is join our Youth Against Styrofoam campaign for the city of Irvine. They canceled the meeting tomorrow night. I don't know, hopefully in celebration of Earth Day. But on May 22nd, it's going to be the Green Ribbon Committee. We've already presented to them. Northwood and Woodbridge did a year ago. And we just want them to ban styrofoam now. It doesn't hurt the businesses. It actually helps the businesses. And of course, it helps us, and it helps our rivers and creeks and streams. Cigarette butts are number one. Styrofoam is number two. And where's the best place to do a beach cleanup? At your home, your school, or where you work. So don't go down to Newport and do a beach cleanup. Do it at your school, do it at your home, and do it at your place of business. That would really, really help us. So Diane is one of my interns from UCI here. We can see her afterwards. So with that, I want to, Captain Moore is going to say something, and then we'll do some more Q&A.
Yeah. I have a couple of things that are really bothering me. I had to fly to London for the International Maritime Organization meeting where I presented to the UN for the ocean. And on the Virgin Atlantic flight, they handed out these polyvinyl chloride, PVC bags with your eye patches, your toothbrush, your earplugs, all the little goodies they wanted to give you. This stuff smells like a new shower curtain. This is the dirty plastic. PVC is toxic. Women shouldn't be smelling it. Babies shouldn't be handling it. It's leaching phthalates, which are anti-androgens. It will interfere with male sexual development. Write to Branson and tell him that he needs to switch his bag from polyvinyl chloride PVC. I would open it up and let you smell it. It smells so bad, but it's toxic. It's the dirty, toxic plastic. The other thing is, we got Governor Schwarzenegger to sign a bill that made it illegal to release those little plastic pellets I talked about, the pre-production plastic pellets. And yet, we take one step forward, we're taking two steps back. These are caps. These are the things that the kids, you can go find shelf after shelf of these in the hardware store that they shoot out of their little BB guns. And I got these out of the alley behind my house. They're roly-poly. They're even better at rolling than the Nurdles are. And I'm finding them, they say they biodegrade. I've composted them for years. I just got through filling up a bunch of pots in my garden. And the compost I used still had the totally uncomposted yellow pellets in it. So they're not composting. They're not biodegradable, not the ones I'm finding. And I just get so upset that we can't seem to make any progress. That we get a Nurdle bill, we get the governor to sign it, and here they invent something that's worse, that is being dispensed by every child. I mean, there's more children than plastic factories.
Okay. With that, if you can tell, we're just a little passionate about the subject. So question and answer time. Does anybody have any questions, comments? Mr. Rowley.
You showed us a lot of pictures of the greater Pacific, but along our coast, you showed us some things at the end of watersheds. But you did some research also on the plankton plastic ratios right on the inshore environment. Could you tell us a little bit about that?
Yeah, off Bayona Creek, we found 1.5 pounds of plastic for every pound of plankton. And it was interesting because we did some studies on the bottom of the ocean there. We used an epibenthic sled so that we could take a sample right above the bottom, plastic hovering right above the bottom of the ocean. And in calm conditions, we actually found more plastic hovering just above the bottom of the ocean than on the surface. We also did a study off San Gabriel River where Seal Beach meets Long Beach and found 2.5 times as much plastic as plankton in the waters off there. And we found the highest ratio ever, I think, in one of our samples, like 130 or something parts of plastic to one of plankton.
Other questions, comments?
There will be an excuse me, an opportunity to ask questions for those in the other venue when we do the reception after this.
Thank you for your presentation. I would like to find out if you have any books or CDs or any kind of something that we could get our hands on to spread this.
Yeah, well, I have the brochures over here, Plastics Are Forever. I have the paper on the San Gabriel River study over here that showed the plastic to plankton ratio in our local waters. And I also have a paper I did, and that's from the IMO conference on a proposal to stop dumping of waste from ships. And then there's also a
Synthetic polymers.
yeah, the synthetic polymers in the marine environment paper.
Comparison of plastics.
Yeah, but you can find all these on our website, algalita.org, algalita.org, and download them there. And also there's some envelopes there. The vessel is in need of repair, and we just, haven't been successful in raising the funds.
And also they have incredible videos that you can buy called the Synthetic Sea that are on the website. He has several different videos, and some are as short as 9 minutes and some are 20 minutes. There's a CD that you can buy called what's the CD called?
Oh, there's a new audio CD out called Plastic Soup, where I have a speaking part.
So there's tons of resources on the website that you can find. Other comments?
Yeah, thank you for your presentation. The stuff you see on the beaches with the kids, and it's all in the water. Wouldn't that be a good place to start getting it before it gets drawn out into the ocean?
Absolutely, yeah. It's very important that with any kind of pollution, the closer you can capture it to the source, the less expense it is to clean it up. So you're absolutely right. I'm a firm believer in structural controls, like the stuff that escapes from the activities that Stephanie suggested, your local watershed, cleaning your local watershed. We'd like to capture that in these catch basin inserts, these screens that we put in the gutters along the streets to capture these plastics. We'd certainly like to use the booms like you saw in Bayona Creek, but our channels are designed for rapid flow. That's why we have the swiftwater rescue teams. Those creeks are flowing at 40 miles an hour during peak flow. You cannot create a screen capture device that will work with thousands of cubic feet of water going at 40 miles an hour. There is no such animal. So they break when you saw them working in low flow situations, but in high flow they have to be removed or they break, and all that stuff flows out to the sea.
I thought, without really thinking that much about it, that with all that stuff floating around, you could recycle it, but you can't recycle it. It's no good to begin with.
Let's put it this way. I talked about some of the problems in recycling, but there's always folks out there trying to create solutions. And one company that I just found out about from a New Zealand friend, I think would be good to have in every disaster relief effort. When we send all these millions of bottles of water to Haiti, they should have the equipment there to recycle those into building blocks to use for reconstruction. And there's a company that's doing that. It takes mixed plastic waste and makes building blocks with holes in it for rebar so that you can actually build structures. Maybe you don't want to live inside one, but you could use it for storage, or you could, use it to stabilize land so that you could build. And there would be a lot of use for that. So I'm a firm believer that we should have recycling infrastructure along with the plastic. We should have instructions on how to use and reuse the plastic when we send it out there. We should let people know that are being introduced to plastic for the first time that it's not biodegradable, that the wicker baskets they formerly used to carry their goods and that they left when they tore and were biodegraded in a few weeks, that's not going to happen with this new stuff. If they leave it by the side of the road, it's going to be there when they come back and their children come back and their children's children come back. It's not going to go away. So this information is not being communicated and the infrastructure is not being provided to take back that material and reuse it. It is possible to reuse it in some rational applications for roads and buildings and things that we want to last forever. Since plastic lasts forever, let's make things out of it that we want to last forever, and let's get rid of a lot of this planned obsolescence, especially with persistent plastics.
Yeah, and I think it's, what you said is valid. And we can't recycle it. Most of the time it is so degraded. So there's two suggestions for that. Number one, when you see any trash, just pick it up. You don't have to be doing a beach cleanup. And people are like, oh, I don't have a glove. And it's like, well, you're going to swim in it anyway, and you're going to eat it later anyway. So what's a little bacteria? You can wash your hand. But the other thing is understanding that the whole life cycle of plastic production, remember it's made from petroleum, natural gas, and a whole bunch of chemicals. So the whole production and life cycle of plastic is damaging to our health and to the environment and to our economy. The County of Orange spends $350,000 a month picking up trash. How many students could we give a college education to at $350,000 a month?
7.
At this day and age. So, people complain about their taxes, yet we spend billions of dollars in the state of California studying the pollution, picking up the pollution, trying to solve it, and we'll have a word from our
And
mayor.
this is being used by Method home cleaning products to make soap bottles. They're going to make some new bottles out of the Gyre debris. Adam Lowry's an ally in this effort to recycle more plastic.
What are the implications of the reinstatement of offshore oil drilling?
It's getting to the point where it's costing us a barrel of oil to get a barrel of oil. They're going so deep, so far out at sea, that they're just barely making money, They have to do a big operation, get a lot of oil in a really big hole to get anywhere with that stuff. And they're using the last of our unrenewable resource. It's just a Herculean effort to screw ourselves.
And your tax dollars are subsidizing it. Okay, other comments, questions? Okay, we are, one more.
Is there perhaps a way to alter the plastic in our production so that's more degradable?
Yeah, it's not so much the oxo-degradable plastics, which receive a lot of hype, are just really metal salts that make it break down faster into small particles, but don't biodegrade necessarily that much faster. So I'm not pushing additives to current petroleum-based plastics, but I do support Metabolics' marine degradable polyhydroxyalkanoate plastics that are made from a fermentation of corn sugars that will degrade under ASTM standards in the marine environment. We do think that if we, like right now, Frito-Lay's Sun Chips is PLA, polylactic acid, which is not marine degradable. It will last about as long as regular plastics in the ocean, even though it's a bioplastic made from corn. Doesn't mean it will degrade in the ocean. It will compost, as I explained earlier, because of the heat and the insect activity and the bacterial activity and the fungal activity. But that's not present in the ocean environment, and PLA needs that in order to degrade. So it's possibly, just as long-lived in the ocean as regular plastic. So the PLA being compostable is a step in the right direction, but I spoke with Brad Rogers at the University of Idaho last week. He's the inventor of the PLA Sun Chips bag, and he's now working to make PHA part of that solution so that he will have a marine degradable plastic in his waste stream. So we can hope for that to be a success.
At the same time, we should be using those bioplastics for long-term plastics, not making a whole, but growing corn, growing all this stuff to make things we're going to throw away in 15, 20 minutes. So, you know, there's a lot of controversy, and we don't like to call them biodegradable. We like to call them compostable because they need to go in a composting, not be thrown out your window. And also, they take a lot of resources. Most of these are not organic corn and soys, so they're using petroleum, pesticides, fertilizers. Most industrial composters do not want the corn base and soy base because they don't compost at the same rate as our food and soiled paper and everything like that.
Yeah,
So
one PLA bottle totally screws up a whole PET melt. So that's why the biota didn't last, is because everybody got so mad. All the recycling programs were getting hurt by having PLA bottles mixed in with the PET bottles. So the persistent plastics that, and by the way, these PET bottles are not bioinert. Dr. Jorg Ullmann, who studies European freshwater snails, had a control batch of these snails, and on a hunch he unscrewed the lid of one of those regular PET water bottles that we all drink out of and dropped some snails in there, and they ended up making a lot more eggs than the controls. There are estrogenic compounds leaching out of those regular PET water bottles that everybody's drinking out of, so they're not bioinert. Anyhow, the polylactic acid PLA bottle that was marketed under the name Biota has not been on store shelves recently, and I think it's mainly because one of those biodegradable bottles in a batch of non-biodegradable PET bottles screwed up the melt to where they couldn't use it.
So try and design things that are reusable, repairable, returnable. That's what we really want, is to get back to that old-fashioned design for durable, for lasting
We
a
really
long
need
time.
good chemists. We need good designs. We need to rethink, as Stephanie pointed out, the whole production chain. We need to eliminate the toxic chemicals. Right now, the United States is a dumping ground for toxic chemicals that have been banned in Europe. We're no longer the leader in safe chemical production. We are the dumping ground now for a lot of unsafe chemicals.
Right. I just wanted to say after this, I mean, it's a very heavy word to receive, and it's a lot and a little bit depressing because it's such a huge problem. But my name's Candace, by the way. I'm part of the Green Team Alliance at IVC here. And I just want to give a small encouraging word, though, that like Captain Moore said, it is all of our problem. And on one hand, we should not feel so guilty or really guilty about, you know, what our lifestyles entail, because it's what's available to us. It's what is out there. So don't feel like you need to go home and like purge everything in your house and like be
I'll
totally
go ahead, feel
pure.
that way.
Okay. Maybe to the feasible extent, but yeah, no guilt necessary. But on the other hand, don't fall into the mentality that, you know, I'm just one person. It's up to the manufacturers to change it. It's up to the scientists. It's up to the government. It's really not. It is up to us. And so, you know, if at all possible, do get involved with groups like, you know, Stephanie with Earth Resource Foundation, the GTA, support Algalita Research Foundation. And if at this time that those aren't things that are feasible for you, the little things that you do, the choices that you make every day at home and at work and at school matter.
Thank you.